Howdy folks, I'm Keith Bowen. This is Hard Rock University, and today I'm in Lauren's shop near Helena here, and I've got a much more spacious and warm location to work in today, which is very nice. We're working mainly wet chemistry today, and we're trying to work on the spot test. And the spot test is based on the fact that this paper will react with gold chloride and aqua regia to precipitate it. Now, Lauren actually has some standard here, 50 parts per million gold and dilute aqua regia. So that's what that spot is. When you take a capillary tube, where are the capillary tubes? Come on. When you take one of these capillary tubes, fill it with the test solution, and stand it on there and just let it flow through, it will react and leave a spot. Now that's 50 parts per million, 25, 12, 6. I'm just diluting 50% each time. Down to 3, that's marginal. I can't tell for sure. I mean, if I was looking at that even under the loop, it's marginal. So my guess is our detection limit is right around 4 or 5 parts per million in the final test solution. Now luckily, we can even improve that sensitivity. This solution right here is some slightly diluted aqua regia with gold in it. I just dissolved some placer gold in that. Very high grade, but we were using it to check certain things. Oh, come on, open up. And there is a kind of solution, I mean a kind of liquid, called methyl isobutyl ketone, used in labs a lot, and it will grab the gold chloride out of an aqua regia solution with extreme efficiency. And I have done this before many years ago with a different manufacturer test paper. I put that MIBK on top, and watch how quick this goes. Just shake it, set it in. See how all the gold went into the MIBK? And once it's in the MIBK, now here's another thing. There was 4 mils of original test solution and 2 of MIBK, so we just got a 2-to-1 concentration. This is an actual digestion. This is one of Lauren's ores. It had a lot of limestone in it or something, so we had to use a lot of acid just to neutralize the limestone first, and then basically make an aqua regia solution to digest. And now we'll see there's 8 milliliters of the ore digestion solution there. And if I put 2 milliliters of MIBK, I will now get a 4-to-1 concentration. Get a cap. As you can see, all of the aqueous solution did not go clear because there's other things in it besides gold. But they tend to stay there while the gold goes into the MIBK. And if you had a bunch of other crud in there, you could even decant that MIBK and rinse it a couple times in distilled or deionized water and pretty much eliminate almost all the other ions except for the gold, to my knowledge. So anyhow, from this we will do another step. The paper does not react with MIBK. You know, you can put that MIBK solution on here and nothing will happen. So now we have to take the MIBK and evaporate it over some more clean aqua regia. And while we're doing that, we might as well take 2 parts of MIBK to 1 part aqua regia and get another 2-to-1 concentration. So this lower detection limit of 4 easily comes down to more like 1 part per million, or 3/100ths of an ounce per ton, as kind of our lower detection limit. And that's the ore analysis. We were hoping to be able to take the Eco Goldex solution, react it with some acid, and essentially turn it into dilute aqua regia. But that stuff seems to hold on to the gold so well, we cannot break it loose at this point. We'll do some more research on that, but as of right now, it is not working. Now this shows another useful phenomenon of the MIBK. Here we have clean chloronitric acid underneath that gold standard, well, high-grade gold extracted into the MIBK. You notice there's no coloration down here. Now this is from the ore. You may be able to see that line right there between the MIBK and the chloronitric acid, but you notice the chloronitric acid is yellow. Well, that's because there's other stuff in that, but that is coming easily out of the MIBK, so we can use that as a rinse and get rid of some of the other crud that might be in interference. So I'll go ahead and rinse that a bit, and then we'll do the same thing like we have here. Now this one, because it was so concentrated, I'm actually going a 2-to-1 dilution, 1 part MIBK to 2 parts chloronitric acid, because I know that's going to be a hell of a lot. This, on the other hand, I prefer to do a concentration because I don't know what's in it, so I want to make sure I get it concentrated so I get some kind of a reaction. Let me get this rinsed and get it started evaporating like this one is. Right now this MIBK is evaporating over the acid, and as it evaporates we'll show you what happens. It's pretty obvious when the MIBK is gone in this case. Not so much in this, but we'll get this rinsed and go from there. Now it's hard to see, but there's the interface there. This is the MIBK from the ore sample after it's been rinsed a couple times. As you can see, we're no longer sending any undesired stuff into the chloronitric acid. The MIBK is much clearer than it was, and got a very light yellow tint or something, not much, but we shall see how it tests out once these evaporate. And this is the high concentration gold MIBK evaporating. As you can see, it's now pretty much transferring the gold into the acid, the receiving acid. There's a little drop, you can see it from up here, of MIBK in the middle, just a little very thin film there that's drying out right now. Once that's done, then we'll be able to test that acid. Okay, so now this is the acid that had the MIBK with the very high concentration of gold in it evaporating over it. It's now transferred. You can see the acid is now yellow. So we take this capillary tube, we get solution in it, and you like to get it up to that line. Clip it in the holder. And as you can see, there's an awesome big reaction, because that's an awesome big amount of gold there. Now, that's just for demonstration of does it work purposes. It's not, I mean, that's so much gold it would be ridiculous. But even that right there is less than the original concentration. If you ever see a spot that big, you're in the money. Then we'll show you the ore sample and see what it does. Okay. So here I've got Montana B. This is digested, and I've filled this with 8 milliliters of solution. Then I'm going to add 2 milliliters of MIBK. There. Now, not only is this fairly dark, but you can see it's also got a lot of turbidity to it. There's lots of particles floating in there. Virtually all of those will not make it into the MIBK, because the reason they're suspended in the acid is because they're hydrophilic and the MIBK is hydrophobic. So it also acts almost like a filter in some ways. You got to let that kind of separate. See, we have, you know, globules of MIBK with other stuff there, and then we just got to do that. Notice how the MIBK is fairly clear. It may be yellow, but it's clear. So we'll go ahead and let that settle for just another couple minutes, and then we'll come back and... Okay, now that we've got the MIBK pretty much separated, and again, you'll notice it's not turbid at all. We want to get all of that we can into here. At the moment, we should have about a 4-to-1 concentration of the gold. And here's something else. If you pull that up into the eyedropper, you can see exactly where the MIBK ends. Take that. This is just distilled water. That. And now we let the MIBK separate. Now you notice in this, we didn't have near as much other stuff in the MIBK, it doesn't look like. But the rinse water is still kind of yellow, so we did rinse some unwanted material out of it. So that looks to be about as clear as that MIBK is going to get. Come on. There we go. There's about 1 milliliter of MIBK. And then we take, this is chloronitric acid diluted 50%. There's a half a milliliter of that. So we get another 2-to-1 concentration. And you can see the acid on the bottom there, the MIBK on the top, and now we just have to evaporate that MIBK to get the gold back into the acid, which we can test with the test paper. Now, one thing we've noticed is that the more stuff that's in the MIBK, the slower it evaporates. Now this is from Montana Bee, Pack Rat Penthouse, and I'm going to take that and test it now, and this should be a pretty good result. Come on, get up in there. There's probably some kind of a little bulb or something to do this. I'm not sure why. Pretty close to full. Yeah, that's how I dropped the last one. Okay. Yeah, I think I'm already seeing a spot, which is not surprising at all. This should be better than 1 ounce to the ton material. In order to compare the spots, you pretty much need to get a series of samples, make spots with them, and then put them on a sheet of paper, tape them down so we've got reference spots over the long term, and you can get a good idea what the grade is. Now this was a 4-to-1 concentration, and it should be a darker spot than that in my opinion. Because we should be running almost 100 parts per million there. And that's not a terribly dark spot. So that's not real encouraging. We will have to do some more research to see if we can figure out why it did that. I remember years ago I had some kind of a interference that would happen that would change it by about a factor of 10, and I was never able to isolate what that was, so it made the test unreliable on unknown ore. Now if you have a known ore and you know that it's going to be off by a factor of 10-to-1, then it's pretty easy to estimate what the grade is of that particular ore. For example, this stuff here is pretty good stuff, and we could probably process down to half or less of that grade. So assuming that it's an interference that's causing this, we could use this test to say basically if you see a spot it's ore, if you don't see a spot it's not ore. And it's something that's inexpensive. and it's relatively fast. The evaporation of the MIBK is the biggest problem. You could probably put it under a vacuum and make it happen pretty quick. But that's the idea, is to give you actionable intelligence in real time, so that, again, like if you're mining, as you're taking out the next level, you know, the next slice, you can actually go, well, what is that stuff there? And find out real quick whether it meets your criteria for ore grade or not. But this is only about, what would you say, that's about a 12 part per million type spot. And I know there should be more than that in there, so I think we're getting interference here. It could easily be that whatever it was that was giving me grief years and years ago, which is why I kind of gave up on this test. But as an ore control methodology, you know, making decisions with a known ore and you know how it behaves, that's a different story. In an exploration situation where you don't know how the ore behaves, then it becomes a lot less useful. So that's basically the state of the art at the moment. We'll continue a few little tests hither and thither and see what we come up with and go from there. Happy prospecting and keep it safe out there.